Alright, so we did section 1 last week. Section 1 last week, we're moving into section 2.3. I skipped over section 2 because it's more of the same stuff. It's highly redundant. So we're going to jump into some formulas. And then using those formulas. So this is just a small list of formulas. I'm not going to expect you to memorize these. I am going to expect you to recognize them, okay? What they do. A lot of times formulas will be given to you. They'll say, hey, here's this problem. Use this formula. They're not going to tell you what each part is. That's something that you need to be familiar with and know, okay? So when we have area of a rectangle, knowing that L and W stands for length and width, okay? Simple interest, we'll be using simple interest, PRT, principal rate and time. We'll talk about that when we do compound interest a little bit later in the class period, okay? It's similar, just, simple versus compound. Perimeter of a triangle, A plus B plus C. D equals RT, distance equals rate times time. That's one that's used a lot, okay? D quite often. Volume of a rectangular solid, length times width times height, okay? Again, this is not an exhaustive list, but this just shows you some of the more common using, as well as what they mean, what each variable means. Solving equations for a specific variable. So we started with solving equations in one variable, and we did inverse operations. So if I had 3x plus 5, I would subtract 5 to move to the other side. I would divide by 3 to get x by itself, okay? We're doing the same thing with our what we call literal equations. The only difference is I can't actually do any subtraction. I can't actually do any division. All I can do is show it. And what that means is in some ways it'll be easier because I don't have to perform any calculations. But it is very important when we are doing literal equations that you take extra care to write neatly and to keep track of your work, because it's very easy to lose track of what you're doing because nothing's getting simplified in a way. We're just moving things around. But we followed, these are all the same steps that we did last week when we solved our linear equations. So starting with our first formula for volume equals length times width times height. Okay? I want to solve for W, which means I want to get an equation in the form of W equals something, okay? I want to rewrite this equation so that I have W equals, and then the rest of my variables are going to be on the other side. Trey, you need something?
It's in our packet, right?
Yeah. Okay? So, first I want you to look and say, okay, well, if I'm trying to isolate W, okay, there's W, let's isolate W. What operations do I have happening to W? L and H is what? Well, what operation? Multiplication, okay? So L is being multiplied by W, and H is being multiplied by W. So I have multiplication. How do I undo multiplication? Division. Okay? So what I'm going to do is I'm going to undo, just like we would if I had 3x equals 6. I would divide by that 3 to get x by itself. I'm going to do the same thing here. I'm going to divide by what's being multiplied in order to get it away from the variable that I care about, so that it eliminates from one side and moves to the other. Okay, it's the same exact process. The only difference is here, I can actually do 6 divided by 3 to get a number. Okay, here I can't do V divided by L and H because I don't know what any of those values are. So it's simply a matter of rewriting it. Okay, I can't actually do the calculation. All I can do is show what's happening. Okay, all I can do is show what's happening. All right. And the benefit of literal equations, usually comes in when we're comparing a bunch of different things. Say I had a bunch of rectangular solids, okay, and I knew the volume, and I knew the length, and I knew the height, and I wanted to see which one has a bigger. Instead of plugging in length and height and volume and then dividing and doing that over and over and over, I can rewrite the equation to focus on width and say, okay, now I can just plug it in and solve much faster, much more simply than having to just do it over and over and over and over and over again. Okay? This makes it a lot easier to offload the work on your calculator and speeds up the process. I've done this a lot with comparing interest on different savings accounts. Okay? Sometimes they have better compounding rates, sometimes they have better interest. So comparing them, rewrite the equation makes the work a whole lot faster to actually do a really good comparison of things. This is the formula for simple interest with the amount in the account. So that's an interest formula, and I want to solve for t. What operation do I have happening with t? I have adding and I have multiplication. Okay? Oops, that's not what I highlighted. This. I've got two operations. Adding and multiplying. So if we go back to our example, if I had 3x plus 7 equals 6, okay, what would be the first thing that I undo? I got to undo the addition first. Okay, so I would subtract the 7. Then I would do the division, right? I'm going to do the same thing here. I'm going to undo the addition first. Then I'm going to undo the multiplication. Okay, so in order to undo the division, undo the addition, I had this p being added to PRT. I'm going to go ahead and subtract p from both sides. So I have a minus p equals PRT. Okay, so I undo that addition first by doing subtraction. You always undo addition subtraction first. So PRT. Now, what am I going to divide by to get t by itself? P and R. P and R. So here, P and R will simplify. P divided by P is 1, R divided by R is 1. So I'm left with just the t. And then I have my numerator, A minus P. My denominator, PR. Yeah, they would not. And unless we rewrite it a different way. So here's the thing. In order for these to cancel, and I'm glad you asked that question. In order for the p's to cancel, all of these terms would have to have a p in them. A minus p is two separate terms. So that's subtraction sign. Okay? All three of those terms have to have the same thing in order to simplify. Does this first term have a p in it? No, so I can't. Okay? But there is another way you can write it. Since I'm dividing by PR, the alternative is that I could take this and I could take A minus P and I could divide each of them by PR. Okay? All this is here is I subtracted fractions with common denominator. I wrote them over a single denominator, okay, here, or I can write them as separate. Now again, A doesn't have anything to simplify with, but the second one does. I could reduce this, A equals PR, that doesn't change, minus 1 over R. I could do that. So I could write it as two separate terms, or I could write it as one term. Generally, this isn't as pretty, so you can do it. Nothing wrong with it. This is a little bit easier. Okay, so nothing wrong with leaving it as one fraction. There will be times where we'll need to, but not today. That was a good question. Any questions on either of these two? Because you're about to try one on your own. Okay. Solve for y. Undo your subtraction first, then undo your multiplication. All right. Cool. All right. You guys did well. We added first. Boom. 4y is 9 plus 5x. Now, convention will say, hey, if we have a term with a variable and another term without, write the one with first. Okay? Just use that commutative property to write the term with the variable before the constant. All right? And then we end by dividing by 4, and this is where we have that, that difference that Beatrice brought up. We could write it as 1, but a lot of times when we're dealing with x and y, these linear equations, is where we see that split. Does anyone remember from Algebra 1 what this form of a line is called? I know it's been a while. Anyone? Yeah. So that's times where we'll want to split into 2, is when we're dealing with linear equations. Okay? We'll spend some more time on this. But that's kind of the differences. So either of these is correct. Okay? Either one. I know I did multiple choice, so I did that. But either one is right. Now, this one's super fun. Oh, yes. I think it's super fun. Yeah. What's the difference between this one and the last time we saw this formula? What about it? You gotta solve for p, but why is that going to be different than solving for t? Twice. Okay, I have p in there. In order to solve for p, I can only have 1. Alright? So what I need to do is I need to turn 2 p's into 1 p. Which means I'm going to undo distributive property. Okay? So I need something in here that if I distributed the p, I'd end up back with this. So p times what would equal p? Squared. P times what equals p? 1 times 1. So if I multiply by 1, I end up back at p. Now, p times what gives me PRT? RT. So I undid distributive to turn 2 variables into 1 variable. You guys aren't nearly as amused as I am. All right. Now, what operation do I have happening with p? Okay, which is what operation? Multiplication. Okay. Now, I don't want to go ahead and distribute because that's just going to undo all the work I just did. So how do I undo multiplication? Divide. So p is being multiplied by this entire thing. So to undo, I'm going to divide by that entire grouping on both sides. So when I have that distributive, I can divide by the entire thing that it would be distributed into. Okay? Divide by the entire thing that it's being distributed into. So then if on the right side, that whole grouping is going to cancel. Boom, boom, boom. That entire grouping cancels. So I'm left with p equals a over 1 plus RT. That's about as hard as literal equations will get. Do that. Easy. Questions, comments, concerns? Any brave souls care to speak up there? Alright, now let's actually use this stuff. On your notes, I gave you a blank slide specifically for this, so you have plenty of space to write, but I'm just going to write directly, okay? I'm going to read this in a second. I'm going to talk about this formula first. This is our formula for compound interest, okay? Most bank accounts have a compound interest yield. It uses a formula very similar to this. Not exactly the same because, banks don't actually want to give you money. So it varies a little bit. So let's talk about all these parts. A, the amount in the account after some number of years. Okay? That's how much money we have at any given point. P is the principal amount invested. It's the money you started with. The money that is earning interest. Okay? The amount invested called the principal. T, time in years. And this is very, very, very important. It's always in years. Okay? I don't care what unit of time they give you. What goes into the formula is years. All right? So if they say it's invested for 36 months, what's my time going to be? 3 years. 6 months. 1 decade. 10 years. 104 weeks. 2 years. Semi-annually. Twice a year. Monthly. Oh, I'm thinking about compounding now. Never mind. 12 months, 1 year. All right? Annual rate of interest. Okay? They're going to give it to you as a percent. You need to write that percent as a decimal. Okay? You always have to write the percent as a decimal. So make sure you do that. For example, 3% as a decimal is what? 0.03. Okay? 0.5% as a decimal. 0.00. So even if they give you the percent as a decimal, it's still a percent. You need to write it in decimal notation. Move your 0.2 spaces to the left. Number of times compounded each year, that's n. So how many times it compounds each year? So weekly would be 52 times. Okay? Monthly, 12 times each year. Quarterly, 4 times each year. Semi-annually, twice a year. Okay? Annually, once a year. And that is the worst account. Never get one that compounds annually. All right? So those are the pieces. Let's go ahead and look at the equation, or the problem now. June Myers received an inheritance of $15,000 and plans to place all the money in a savings account that pays 3% compounded quarterly to help her son go to college in 5 years. How much money will be in the account in 5 years? So looking at the question, the actual question here, how much money will be in the account in 5 years? What variable am I solving for? Which one tells me the amount in the account? How much money will be in the account in 5 years? I'm solving for A. Okay? Hold on, let's fill in the formula first. Okay? Principal. How much is being invested? 15,000. So I've got 15,000. Okay? Time. How long? In years. It's always in years. 5 years. Annual rate of interest. 0.03. Okay, that 3%. 0.03. Number of times compounded per year. 4. Because it's quarterly. Okay? So, it is very, very important that you fill in the formula without any shortcuts. Because your calculator's going to do the heavy lifting. Okay? If you got your TI-84, get that out because we're going to use it in a second. Alright? The calculator can do your heavy lifting, and that's fine. So, A is our principal, then 1 plus our rate over our compounding frequency raised to the power of our frequency multiplied by time. When you're doing an assessment, as long as you can show me the formula with everything in the right spot, even if you make a calculation error, you'll get most of your points. Okay? As long as you can show me this, you'll get most of your points. Alright? I need to at least see that. But let's go ahead and put this in our calculator. Clear that. Clear that. Alright. And I want to emphasize, seriously, the required calculator for the class is a TI-84. You need to get it sooner rather than later. You will not be allowed to use any other calculator besides the TI-84. So you need to get it sooner rather than later. Okay? Do not practice with a calculator that is not the one you'll be using on your exams, because then you're going to get to your exams and be like, I don't know. Okay? So get the calculator you need and practice with the one you need. Okay? So we're going to start with, what's the first part of my formula? 15,000. Okay? So type in 15,000. 15000. Okay? Now, the next part's in parentheses. So, boop, start a parenthesis. Alright, what's the next number? 1 plus. Okay, now, does anyone have the big thick version that doesn't do fractions? I think a couple of you. So here's how you put a fraction. If you have one of the thin models, you can press green, this alpha button, and then the button right next to it is going to give you a fraction. But if you have one of the thick models and the fraction doesn't work, what you can do is just another set of parentheses with division. Make sure you double close it though. That's going to be the hard part. So if you have the thick one, there, and Beatrice, okay, you have to do an extra set of parentheses for the fraction, okay? But if you've got the newer one, no backspace, you can just put in the fraction with your numerator and your denominator. Okay? And then this part is really important. Close that parenthesis. You gotta close that parenthesis or you will get the wrong, because you'll be raising the wrong thing to the exponent. What button in here lets me do an exponent? That gives me squared, but it only gives me squared. My exponent in this one's not squared. That button lets you do the exponent. For the little up arrow, see it highlighted in red right there? That lets you do an exponent. Yeah. Compounded quarter. Okay. 4 times 5, and then we're good. Also, if you've got the big thick models for the exponent, you may need to put that in parentheses if you have more than one thing up there. Okay, so $17,417.76. If a money problem does not tell you where to round, you need to round to 2 decimal places. Okay, 2 decimal places. Sometimes they'll say whole dollar, or nearest $100, or nearest $1,000. But if they don't specify, you need to make sure that you're writing in 17,417, right? And 76 cents. Boom. Okay? Easy peasy. Now, I will say, this is the kind of stuff that the 84 Plus is the best at because it lets you do the fractions more easily. You can do it on any model. I'll make sure that you know how to do it, but you need to make sure you know how to do it. Okay? Questions, comments, concerns, queries, or conundrums. Now, I'm going to ask you a series of questions regarding this problem. First, the average speed of a cyclist across the continental United States is 15.4 miles an hour. If he traveled a total distance of 3,107.5 miles at this speed, find his time cycling. Which of these formulas would I use to find his time cycling given a distance and a rate? emphasis added. Just click the one. Distance equals rate times time. Okay? So now what we're going to do is we're going to take those numbers and we're going to plug it into that formula. Tell me which one does it correctly. Tell me which formula plugged in those values correctly. Yes. Oh, actually, are any of you sophomores? You have the assembly in the auditorium. Freshmen and sophomores have the Distance and rate. Distance and rate. Now, solve for time. Do not round. Yeah. This class ends at 55. Do not round. Write it as is. It's going to be a big long number.
I rounded. Yeah.
Woo! Do not round. All right. Fun fact. There's your answer.
Yeah, these tools not you know.
Literally underneath. Okay? Now, that number is in hours. We took the distance divided by the rate in miles per hour. And since we went 3,000 miles at 15 miles an hour, what we get from that division is hours. Now, we want time in days, hours, minutes. So now we got to take this and convert it into days, hours, and minutes. So let's start with this 201. How can I figure out how many days 201 hours is? Divided by 24. Okay? So 201 divided by 24 is what? How many? 5. Okay, so 8 days, right? 8 days. That's a really bad D. Okay? 8 days. Now, I have that decimal, and I also have decimals left over. Okay? So here's what I want you to do. What is 24 times 8? 192. 201 minus 192. 9. Okay? So after I take this 201 and a bunch of hours, and I take 8 days out of it, I'm left with 9. If I could write a 9. Oh, apparently not. 9.7857143. 3 hours. Okay? So I have 8 days, and I have 9.7857148 hours. Okay? So now how many hours do I have? 9. I have 9 hours. Okay? 8 days, 9 hours. Okay? So now I'm left with 0.7857857148 hours. God, why is it writing so badly? 8. Trying to write fast, that's why. Okay? How do I figure out how many minutes that is? Divide by 60. Multiply by 60. Okay? So take that number, multiply it by 60, round to the nearest minute. Nearest whole number. 47 minutes? Boom. 8 days, 9 hours, 47 minutes. We did it! We finished with 2 minutes to spare.